Okay, yeah, sorry for the disconnect. Now, the variance is a measure of the spread of data as well. Just like range is, range measures the spread, so with variance. Okay, how do we know that it measures the spread? Look at it. Is the average squared what? Difference. Difference from what? Mean. Okay, now somebody should tell me, I want you to give me synonyms for difference as used in this particular sentence. I want to have synonyms. I want to hear from you. What would you use as synonym for this word difference? Are we still there?
Subtraction.
Subtraction, okay. Thank you, sir. Subtraction. Yes, thank you. Any other synonym? Synonym for difference. As used in the particular sentence. In that particular sentence.
Part of deduction.
Deduction, okay. Thank you. That's right. Any other synonym? Okay, let me share something with you because I really want us to get this thing. Let me share an online. Let me share something with you. Now, see, I just typed synonym for difference here, okay? From Google. I want us to see for ourselves so that you see what I'm talking about. Can you all see my screen?
Yes,
Can you see my
yes.
screen? Okay, now I want to take you to some of them which I want you to pay attention to. These are all synonyms, the similar, unlike, and all that. Okay, look at this. Look at this. What's this? What can you see?
Divergent.
Divergence. Measures of dispersion. I said before that they measure how data diverges from the center. Look at this one. Disparate, dispersion again, okay? Look at this. I like this. Can you see this one? What does it say?
Poles apart.
Poles apart, spread, distance. Poles apart. What does poles apart tell you? It tells you the distance, okay? The spread, how far apart they are, okay? All right, so I think that's enough for our purposes. So are you following me now? Can you see why I'm trying to show you why those terms are used to describe them? When we say measure of dispersion, what it's actually talking about. How far apart the data spread from the center. Okay? Yeah. So let's also look at the next one, standard deviation. This is the square root of variance. Okay? Don't forget, when you are calculating variance, you have to square some values, right?
Yes.
Average squared. Okay? So to bring it back to normal, to bring it back to original, that's original value range or something, you need to find the square root, isn't it? Opposite of square is what? Square root. Okay?
Okay.
Yeah. So there's a reason why square is used. When we get to the computation part, I will explain that. I don't want to delve into that right now. But in variance, some values are squared. So standard deviation is the square root of variance, which means what you squared before, you are now bringing it back, okay, to the normal value, magnitude, or something. Okay, so now look at this. So therefore, since standard deviation is related to variance, if standard deviation is a measure of dispersion, then if variance is a measure of dispersion, then standard deviation also has to be a measure of dispersion. Square root of variance representing the average distance of each value from what? From the mean. It represents the average distance of each value from the mean. That's what standard deviation is about. Okay, so it's a measure of dispersion, it's a measure of spread from the mean. How data spread from the mean. Therefore, if the standard deviation is small, that would mean that the data kind of is slim. It's kind of packed together. Packed. But if standard deviation is high, which means the data distribution is sort of wide. Are you following now? It's wide. Right. So there are measures of spread of data. Then we have the interquartile range. Can remind us what is this about? Anyway, it is here. Is the range within which the middle 50% of data falls. The interquartile range is the difference between the first and third quartiles. Okay. The first and the third quartiles. We are going to solve problems on this, so don't worry about it. But the first quartile actually is, like when you are dealing with median. What is median? Median is a measure of central tendency.
Central tendency.
What is median?
Which is the
How would
middle,
you describe median?
the middle number.
The middle number, okay? What other word would you use to describe such a thing? The number that is kind of halfway, right? At the center.
Yes.
Which means if you divide the data sets, the values, into two parts, into two, the median would be at the center. It's halfway, midway, right? Isn't it? Halfway into data, yeah, that's median. Now, but if you take 1/4, that will give you the first quartile. Instead of half now, when you take half, that's halfway within the data, midway is median. Sorry. But when you go 1/4, that is to say, assuming, you are splitting your data into 4 parts. Okay, that first one, that first part, the end of that that's 1/4. When you split it into 2 and split the other, the lower part into 2 again, that's 1/4. That gives you the first quartile. Okay, then if you move through 1/4 of the values again, that will land you at the middle, which is second quartile, which means second quartile is the same thing as median. If you go again by 1/4 of the number of items as you progress towards maximum, that will give you the third quartile.
Quartile.
Okay, so third quartile minus first quartile gives you IQR, which is the interquartile range. Okay, now it shouldn't surprise you that we are explaining these kind of things. We are explaining this so that these calculations, when you are doing these calculations, it goes beyond just calculating some things and getting some answer. You have to know exactly what it's about. Okay, and that is what helps you to be an effective analyst, because data analysts should understand data. You should understand the nature of data. You should understand data distributions. You should understand how data is distributed, how it is shaped. Okay, you should don't forget we are dealing with what? Descriptive data. We are trying to describe, data. That's what we are doing now. We are trying to describe. How do we describe data? Okay, that's the beginning of the journey to becoming an analyst. Okay. All right. So we have talked about measures of central tendency. We have talked about measures of dispersion. Then we have data distribution and visualization, which is also a very important aspect of measures of central tendency. Of course, there are other measures, but those ones are sometimes we talk about, for example. Hello. As we get on, you see we'll talk about some other things like sometimes we use the term measures of position and all that, but generally these are the most important. Okay. Now, data distribution and visualization is also an aspect of descriptive statistics. Okay, it's an aspect of descriptive statistics. Now, descriptive statistics also involve graphical representation of data to identify patterns and relationships. Okay. So, like now, so I told you at the beginning of this class that there is descriptive statistics, okay, and there's also inferential statistics. Descriptive statistics talks about summarizing data in various forms and also presenting data in ways that can provide insights, very useful insight. And this insight can help in making intuitive, very sound, effective decisions. Okay, that's the purpose of descriptive statistics. And sometimes in most of the work that analysts do, many analysts don't even go beyond descriptive statistics. Okay, they just get those summaries, do presentations, and with that alone, in some cases, that alone is enough to solve the problem that is meant to be solved. Okay, but there are some cases where a higher level of technicality is required. Maybe, for instance, there's need to make some predictions. That's where inferential statistics comes in. Okay. Now, we're also going to talk about inferential statistics because, like I've said, we are looking at analytics somehow from the perspective of data science. Okay. Yeah, we don't just want to stop at the level of the general standard data analysis. We want to go at least a little bit beyond that, so that if you choose to migrate into data science, you find it very easy. Okay, so that's why we are doing this. Now, so we just talked about measures of central tendency, measures of dispersion. Those kind of summarizes data in some form. Now, there's also what we call data distribution and visualization. The data distribution kind of tells you the shape of the data, okay? Maybe the data trends, those kind of things. The data distribution, is it symmetrical? Is it skewed to the left, to the right skewed, left skewed, and all that. So those are important things, important information that the data analyst should also be able to have and be able to convey. Descriptive statistics also involve graphical representation of data to identify patterns and relationships. Now, there are several tools that can be used for data presentation, but here are some of the most common ones, okay, that standard analysts use, standard data analysts use. Okay. When I say standard data analysis, I believe you know what I mean. That's to say, what I mean is, don't forget we are dealing with descriptive statistics now, not inferential statistics. Okay. Yeah. So you may wonder there are some type of charts I've not mentioned here. Not that they are not useful, but they are used more by, for example, scatter plots. Scatter plot is used by analysts, is used by data scientists, but you see that data scientists tend to use such tools a lot. And they drill down, more than many general analysts. Okay, so let's just take it. Now we have this. These are the most commonly used. These are the most commonly used. Okay, we have the okay, let me start from the top. We have the histograms. Histograms are used a lot. What are histograms used for? They are used to play the frequency distribution of numerical data. Histograms are used mostly for grouped numerical data. Okay, numerical data. Can you give me an example of numerical data? What do I mean by numerical data? Now, somebody give me an example of numerical data.
Like ages of people.
Ages of people. Okay, thank you. That's numerical data. Yes. Any other example? Any other example of numerical data? What about heights of people? Is that numerical data?
Yeah, height as well.
Numerical data.
Yeah.
Okay. What about stock prices? Is it numerical data?
Top prices. Yeah, sure. Yes.
Do we all agree with him?
Yes, I agree.
We agree with him. Okay. What about the position of a student in class in a test?
It's numerical.
Is that numerical data?
We call that categorical. Categorical data.
Okay.
Categorical data.
Yes. Okay. Okay. However, we are going to treat all this. I just wanted to ask. Yeah. So, um, age, height, stock prices, Bitcoin prices, those kind of things, they are numerical data. Okay. Yeah, they are numerical data. Okay. But now there's something about numerical data that makes it unique. What makes it special? What makes it kind of different from categorical data? What makes it different from categorical data? Let's say, for example, let me give you an example of data that is non-numerical data. Let's say, for example, you have data that is used to represent age distribution. Age distribution. Okay. I don't know what age categories do we have? Maybe we say 0 to something, 10 to that. Okay. Such data will not be numerical. Okay, because you are dealing with this age distribution. You say, okay, all the people from 10 years to 20 years, let's say it's in a school or some workplace. Let's say the lowest age to start work there is 18 years. Let's say 18 to something, maybe 18 to 29, 29 to something. You see that you have a few categories. The categories may just be like 5 groups, 5 age groups, or 6. Are you following? Or 4. So you see that the number of items you are dealing with is kind of few when you are dealing with non-numerical data, data that is not numerical. Numerical data usually have a lot of variation, a lot of different values. For example, you want to measure the height of, you want to show something that shows the height of all Nigerian ladies, for example. Okay, there are different heights, 5.8, 5.82, 5.902, 6.015, or whatever, depending on the number of decimal places you are working with. You have many values, okay? All right, so histograms are meant for numerical data, which means it can handle a huge number of different values, but usually it's expected that these values are grouped when you are dealing with histogram, okay? All right, so another commonly used one is the box plots. Box plots. Yes. Box plot can be used to show the spread of data, the median, the quartiles, and the potential outliers. Okay. Yeah, I may not be able to say much more about a box plot for now. As we get on later in the course, we'll see it. Okay. But when you say quartiles, what do you think we mean by quartiles? He's talking about the first quartile, second quartile, and third quartile. Okay, that's what this means. So the box plot shows the spread of data. It shows the spread of data. Okay. Yeah, for some of us, we may not have seen this before. So let me just give me a minute. So it doesn't sound too abstract. Let me show you. Just a minute. I actually post directly. Wow. Okay. I think that was around okay. Okay, so that is that. We've looked at the data distributions, the histograms, which are used for numerical data visualization, the box plots, which show the spread of data, which shows the median, quartiles, and the potential outliers. Then we have the scatter plots, which are used to analyze relationship between two numerical variables. Then we have the bar charts and pie charts, which are used for categorical data representation. Okay, so we also have looked at the applications of descriptive statistics. Okay, descriptive statistics are widely used in various fields. They are used in business and finance, for analyzing sales data, customer preferences, and financial trends. They are used in healthcare for summarizing patients' data. Okay, monitoring disease trends and evaluating treatment effectiveness. They are used